Okay, 10.6, systems of conics. So we are taking systems of equations that we did first semester and we are multiplying it by exponentially. Like we're gonna start looking at a lot more functions to find systems of. And what I mean by systems is where they intersect. So things that we could graph or we could find the points of intersection from can be, I could ask maybe a line, I could ask a parabola, circle, ellipse, hyperbola. So these are the things that I could ask you to find the intersection between, like 2 of the 5 choices. These are all the options. And before we even solve a system, we're actually going to identify like what kind of equation it is. From there are several options of solutions that you could have. So you could have no solution. And no solution would mean that they never what? They never intersect. You could have 1 solution, 2 solutions, 3 solutions, or 4 solutions. So we could have any of these combos. And I'm going to try to show you, so this will be in the non-calculator portion of your test because it would be really easy to just type it in your calculator and get an answer. But I want to show you what that kind of looks like and be able to identify what these solutions would be or what it looks like when you have 2 solutions or 3 solutions or 4. So this is number 1. Number 1, we are not going to solve algebraically because it kind of has an ugly decimal, and I'm not going to give you any ugly decimals on a non-calculator part. So here we have a circle and a line. So the circle is the x squared plus y squared equals 8, and the line is the 1/2 x plus 1. And so how many points of intersection do I have? 2. Here and here. Now one of them looks like an easy ordered pair. That would be 2, 2. The other one is kind of the ugly one at -2.8, -0.4. So if you want to write those intersection points down, you can. We're not going to solve it algebraically because of the decimals. We have one at 2, 2, and -2.8 and -0.4. I also want you to label, like the top equation is a circle. How do we know that that's a circle by just looking at it? A and C are the same. And then why is the second one a line? Y equals mx plus b. The circle and line combo, it could obviously have 2 solutions because we see it here. What are the other options of number of solutions that this could have? 1. Yeah, if it just touched it like this, it could just have 1 solution. Or it could have no solution if it were way out here.
Oh, so the solution is like wherever it crosses.
Mm-hmm. It could never have 3 or 4 if it were just a line and a circle. Okay, let's look at number 2. And first, let's identify what kind of graphs they are. So what is the first one? X squared plus y squared equals 25. It would be a circle. I'm just going to put a C next to it. And what about the second one? X plus 3 squared plus y squared equals 16. It's also a circle because the A and the C are the same. So how many solutions could that have, do you think? If we have 2 circles that are intersecting. Maybe like 1 or 2. So I'm going to graph it. I'm going to show you what it looks like. I'm going to show you. So here's a graph. I've got two here and here. What are those ordered pairs? Can y'all read that?
-3, 4.
If you want to write these down, you can. We're going to check it algebraically. So when you're doing your homework, it doesn't hurt to use a calculator or use Desmos. I don't really like using the calculator to graph conics. It only works on an Inspire too. So if you have an 84, if you want to graph a conic, you have to solve for y on both of them, and that takes too long. So I just say use Desmos. You can graph a conic on an Inspire. The one thing an Inspire can do. Okay, so when you are doing this, for number 2, when you have an x squared and a y squared, like you have both of them, normally when you're solving, let's say by substitution, you solve for one of the variables. Like you solve for x, you solve for y, you substitute it back in. It is socially acceptable when you have an x squared and a y squared to solve for x squared or y squared in this case. Like you don't have to square root the whole thing to get y by itself. So here we have in the top equation an x squared and a y squared. In the bottom one we have a y squared. So it would be really easy to use substitution for y squared and then solve. Mm-hmm. So it works out to substitute for x squared or y squared when you have both in both equations. And so I'm going to take this top equation and I'm going to solve for y squared. So y squared equals 25 minus x squared. Now, I'm going to take this equation and I'm going to plug it in for y squared in the second one. And so I'm going to rewrite this as x plus 3 squared plus 25 minus x squared equals 16. Probably should have given y'all more room. And from there, you'll want to FOIL everything out and refactor to get the x by itself, or get the solution. So if I were to factor the first equation, it would become x squared plus 6x plus 9. Plus 25 minus x squared equals 16. Now I want to solve for x. Something nice about this is what happens. Yes. Makes life a lot easier. So then I have 6x plus 34 equals 16. (6x) equals negative 18. And x equals negative 3. Now so why do I have two solutions but I only have one x value? They both have the same x value, so what do I need to do with this negative 3? Because I want my answers in ordered pairs, right? Maybe write that at the top, because this is something that a lot of people forget, is that your answers must be in ordered pairs. Otherwise, I will not accept it. So what do I do with this negative 3? Plug it into both equations, or you can just plug it into the top one. It doesn't matter. When I plug it in to, let's say, the top one, I get negative 3 squared plus y squared equals 25. 9 plus y squared equals 25. Y squared equals 16. So y equals what? 4 and negative 4. So plus or minus 4. So that makes my ordered pairs negative 3, 4, and negative 3, negative 4.
Why were they both negative 3?
Because they both have the same x value, because one was stacked on top of each other. You remember seeing that picture? So it looked like this, where they both had the same x value but different y values. It's kind of what the picture looked like.
If they were supposed to be
But how do
different,
you
would you
know
go in the quadratic?
Mm-hmm.
How do you know that from like that?
How do you know like that they're both the same x value? Because they're on the same like vertical line.
No, like how do you know it from without the picture?
You don't. So what you would do, I mean, once you get x equals negative 3, you plug it back in. When you get y squared equals a number, or anything squared equals a number, it's always the plus and the minus of that.
So one of them will always be the same.
Yeah. Like it's always the plus and minus when you take the square root of any number.
Is there always going to be 2 ordered pairs? Oh, that's just the number of solutions.
Mhm.
Just kidding.
Okay, number 3, we are going to just identify what they are. There is an ugly decimal in number 3. So, the top one is a what? Circle. The bottom one is a line. I want to give us more room for number 4. Number 4, we have a, what's the top one? Circle. The second one is a line. Yeah, it looks kind of weird. So with these, I personally prefer always doing substitution in solving systems with conics, because it's easier to plug back in. But elimination will also work. Like in number 2, I could have used elimination if I multiplied everything by negative 1 and then crossed the y's out and then added up. So also know that you can do elimination. This would have been x squared minus x plus 3 squared equals 9. And then you could have solved that way. So you can do elimination with these. I want to mention that. I just usually prefer substitution, so that's why I'm more partial to that. Okay, so number 4, we're going to actually solve this without looking at a graph first, because I don't want you to rely on that, and then we'll check the graph lastly. So if I were to solve this by substitution, let's look at the second equation. What could I solve for? Y equals, so if I solve this one for y, you get y equals x plus 1. I just moved this y over and moved this 1 over. Then I substitute it into this equation. So this is an example where you would have a quadratic, and we'll see different x values for ordered pairs. So x squared plus x plus 1 squared equals 13. Notice that I put the x plus 1 in parentheses. To solve this out, what am I going to have to do with that x plus 1? I'm going to have to FOIL it. Not on this one. I won't make you do quadratic formula. I don't like it. All of them will be factorable and will be nice numbers. So what I want you to do now at this point, I want to get everything to one side. I want to factor and solve. So try doing that. You can actually take out a greatest common factor, right? And you get, I'm going to come over here. if you pull out a 2, x squared plus x minus 6. Yep. Mm-hmm. So when you're solving, you set these both equal to 0. Does the 2 matter? No. No, you don't even need it. Because if you divided everything by 2, this would just go, it would still be 0. So when you're solving, you're just setting the stuff in parentheses equal to 0. The 2 does not matter. So x equals what and what? Am I done? No, I need to plug in. Which one is easier to plug into, the circle or the line? The line, yes. So if I can even plug into this one actually. It's easier.
If you plug into the circle, you get plus or minus, don't you?
Yes.
But you have to do it twice anyway,
No. Just plug it into the line.
I mean, do you have to do it to both of the x's?
Yeah, you'll have to do it for the -3 and the 2. Yeah, so you would want to plug it into the line because if you plugged it into the circle, you'd get 2 answers and you wouldn't know which one to choose. And so when I plug in -3, -3 plus 1 is -2. And 2 plus 1 is 3. Yeah.
So how do you know
How many solutions there are?
X goes with Y?
It's the one that you plug in.
Yeah, this is the one that I plugged in. Let's look at number 6. So we have a circle, we have a parabola, and we have a line. How many solutions does the system of equations have? So when all 3 intersect? Just one. This is an SAT problem. I've seen it a lot of times.
It just asks you how many there are.
But a lot of people say 2 because of this. One solution is where all 3 equations intersect. So you're looking where they all intersect, and they try to trick you because some people would say 2 or maybe 3 because of this one right here. Only one. Here's some more examples where we have like a circle and a parabola, or a hyperbola, sorry. A circle and a hyperbola. And here's the different kinds of solutions that you could have just depending on where they're located. So the first one has how many? No solution. Second one has 1, third, 2, fourth, 3, right here. You might want to label them. And then the last one, 4. So this is just some pictures. The most you can have is 4. Just some pictures of what that would look like.
Are we going to have to be able to do that? Like, draw our own graphs and figure out how many solutions?
Okay, let's look at 7 and 8. So 7, we have a circle and a line. How could I solve this?
You do y equals -5.
So y equals -5x. Substitute it in, so x squared plus -5x squared equals 416. Notice that I put the -5x in parentheses So what ends up happening when I square the negative 5x? So 26x squared equals 416. What is 26 or 416 divided by 26? And x equals plus or minus 4. Now, it tells me in the problem that x is greater than 0. So it has to just be the positive one. And when you plug it into the line, you get what ordered pair? Negative 20. Good. And then it says, what is the value of x minus y? I guess this is kind of like an SAT problem. So x minus y would be 4 plus 20.
Why is it negative 20 and not positive 20?
Because negative 5 times 4. So x minus y would be 24. If it were, I guess it just asked like a follow-up question. Okay, number 8, we're not gonna actually solve because you get a decimal. But I want to identify what they are. So the top one is a circle. Second one is a, we do a lot of those if you haven't noticed. Okay, so number 9, we have, what kind of equations are they? The top one is a parabola. The bottom one is a, and they're both already in y equals form. So what can I do? Just set them equal to each other and solve. So I want you to try doing that. It should be able to factor. Okay, so setting them equal to each other and solving. 1, 4. Yes. I was testing you and you passed. Proud of y'all. I think I just saw that 3 there and I don't know. If we imagine that these were x's and y's, because the second one is a little bit harder to identify. So imagine that this were x and y. The first one would obviously be a what? A line. The second one is a little interesting. It's a what? It's a rational, exactly. So imagine if this were xy. If you had like xy equals negative 12, and I solved for y, it would be y equals negative 12 over x. Now what does that remind you of? Yes, the rationals. So it's a rational, like the 1 over x kind of thing. So I guess you can add that to that list. I didn't put that on there. They're not that hard to solve. Yeah, so add rational to that list. That was the whole last chapter. But parent functions are still on this test. Remember that very 10.0 way back when? Still need to know what that is?
Oh, I forgot that we were part of the chapter.
Yes. So, okay, if I want to solve, then I can use substitution. I would suggest maybe solving this equation for b. What did you say?
Yeah, make them both equal.
Yeah. Make them both equal to b. So b equals 1 minus a. I plug that in here. A, 1 minus a. equals negative 12. A minus a squared equals negative 12. You could do x and y if you're uncomfortable with the a's and b's, but I want you to feel comfortable with them because they might show up. I want to make my a squared positive, so I'm just going to move both of these over to this side. So that makes life easier. How do I factor that? Yep. Which one's the negative one?
3.
Or the answer I said, like A.
Oh, yeah.
Okay, I see where you're coming from.
Oh, you have full answers.
So if my ordered pair were in A, B form, then my ordered pairs would be 4, negative 3, and negative 3, 4. So this one, do y'all want to see the graph of this one, or do y'all not really care that much about it? I'll try to draw you what it would look like, because I just think it's fascinating. So this, like the rational one, would look something like this. And because it's flipped, you know, the negative makes it flipped, right? And then the line would be a y-intercept at 1 and a negative 1 slope, so it'd look something like that. So then it intersects here and here. Negative 3, 4, 4, negative 3. It's fascinating to me. No, I'm just showing you. Do you ever want to just know what it looks like, or are you just curious?
Just trying to get the right answer, you know?
But if you visualize it, it helps you get the right answer. You need to have some number sense, like, does this make sense, you know? If you got a weird solution, it may not make sense. So try the next one. If it's a circle and a line, we're like pros at that now. Let me see. Oh, that's okay. That's not a weird fraction.
Because then we have to square that, don't we? That's going to come up.
It won't. You won't have to square it because you plug it back into the line. On the homework, can you, so for number 2, I want you to just identify what they are because you get a decimal, so just identify.
2?
No, do number 1.
Whole thing?
Number 1 is good.
Okay. And the whole thing's identified?
No.
Oh, okay.
Can you listen? Number 2, you identify. Number 1, you do. You'll get 4 solutions for number 1. You'll get 4 solutions because what is the top one? What kind? And what is the bottom one? A circle. So a hyperbola and a circle. And so when you have x squared and y squared, what is the steps? Like, what do you solve for when using substitution? Solve for y squared, right? And these actually eliminate, so it looks pretty nice. So when you get x squared equals something, you'll get the plus or minus x value.
Can you do something to help me real quick? Do you want to like write on the board like the different like what makes a circle, like what signs and stuff again? 'Cause I kind of forgot.
Yeah, I can do that.
Like the
The rest of them, let's see. Number 5. Number 5, I just want you to put the number of solutions. So So just graph it in your calculator or graph it in Desmos and put the number 5.
So graph and decimal.
Yeah. Because they get decimals. So 2 and 5, you get decimals.
So like on the test, we won't have any with decimals?
No, not on, no.
Swag.
And then the rest of them should be good. Yeah, the rest of them should be good. If you want to do the extra practice problems, please feel free.